Hello everyone, and welcome back to the ASE Lab's tutorial series on extended reality, immersive analytics, app development in Unity. As always, my name is Bryson, and in this video we will be performing a fairly comprehensive overview of MRTK and what specific features and pre-built assets it has to aid us in our development of extended reality applications. So, let's get started, shall we? To get a general overview of what MRTK offers for us developers, let's go and take a look at their website. So to access it, all you need to do is simply Google MRTK, and instead of going to the main MRTK website here, we simply just go to the second link, and you'll see here that it just says MRTK Unity Developer Documentation, and you'll get to a page that is exactly what I have here. Now, if we scroll down a little bit, we can see a section regarding all the features that MRTK offers us, and I'm going to start by doing a synopsis of each of these in order to give you all a good overview of what to expect from MRTK. So first off, MRTK's input system is arguably one of the biggest things that it offers developers, and that is because it allows us to take input from different devices, specifically the different types of controllers across these devices, and abstract these down to a generalized input that allows us to interact with objects within the Unity scene in a generalized way, so that essentially, regardless of if we're using a hand, VR controller, mouse, or handheld controller, we can interact with game objects in exactly the same way. So for instance, if you wanted users to be able to select objects and move them about in a scene, an AR user with eye tracking and hand tracking might do this by looking at the object, holding up their hand and doing a pinch gesture in the air to select it, and then moving their hand around to move the object. In the case of a VR user, they might naturally want to do the same interaction by pointing their controller towards the object, where a fishing line coming off the top of the controller would then point towards it, in which case they would then pull the trigger on the controller to select the object and move the controller to move the object accordingly. In a third case, let's say we have someone on a computer monitor where they're using a mouse, and they would simply just hover over the object, click down on it on their screen to select it, and then move their mouse to move the object about the scene. Now, even though these are entirely different ways for users to naturally interact with the object, but just on different devices, through the generalization that MRTK's input system provides, these inputs are abstracted down to be easily communicated to our application, that in each of these three cases, the user is simply wanting to hover over, select, and move the object in the same way. This ability to allow users to interact with your application in the same way, regardless of what type of device they are using, is one of the big backbones of what MRTK offers. As mentioned previously, it allows us to create a single application with MRTK and then deploy this to a wide variety of devices, while knowing that our application will be able to work the same and provide the same sorts of interactions with users, regardless of what device it is deployed on. Now that we have this key feature out of the way, let's head back and take a look at the other features. On a related note, as you can see here, MRTK offers hand tracking and eye tracking capabilities. This profile feature we'll get to at the end, just because it kind of covers a number of things. So the next thing we'll look at is the user interface and user experience building blocks that MRTK provides. So we'll go into this in a bit detail at the end after we go through all these features, but MRTK offers a wide variety of user interface and user experience tools, both scripts that we can use to make our own custom assets, but also a wide variety of pre-built assets for us. And we'll get to this in a second, but as you can see here, there is a wide variety of tools that are at our disposal that we can leverage in our own applications that ease our development process quite substantially for providing extended reality interactions within our application. The next feature that we come across is solvers. Now, solvers are essentially scripts that help us position objects either in relation to other objects or the user themselves. So some of the most common uses of solvers are having objects tag along with the user as they move around, or having objects constantly being placed in front of the user so that if they move their head, the object moves with them so that it's always in their view, or using solvers to place objects around the user's hands and controllers, such as maybe if they have UI elements around the hand or controllers, then you can have those track and move around as the user moves their hands. The other use is for tracking objects in relation to other objects in your scene. So for example, there's solvers for having objects tracked between two objects, objects that essentially orbit other objects, or using a solver to indicate a direction to another object that then indicates that direction to the user. And so there's many different ways you can use these solvers, but that's just a couple of the main ways that solvers are usually used. And these really save us the hassle of doing the math and hierarchies of objects and stuff ourselves, and just saves a lot of time so that we can easily place things in reference to other objects or the user without needing to worry about all the math to do so. So the next feature is the Multi-Scene Manager. And this really is only applicable to those of you who are wanting to use multiple scenes with your Unity project and switching back and forth between multiple scenes, such as different levels. In the case of many of you, though, you likely won't need to use this if you are just doing your application within a single scene. But this is to just help facilitate the exchange between multiple scenes and using MRTK's built-in system to do so. So the next feature we'll go to is Spatial Awareness. Now, this is only applicable to those of you who are dealing with headsets such as the HoloLens 2 that can scan the surrounding environment around you and make a mapping of that environment as a mesh. And the Spatial Awareness system in MRTK basically allows you to use that and use the mesh to do interactions with other things within your scene. So for example, if you have like a holographic cat that you want to jump up on a real world table, you would want to enable your spatial awareness system to do that mapping of your environment so that your holographic cat could walk around and jump up on things that exist in the real world. The next feature we'll talk about is the Diagnostic Tool. Now, you may have noticed this tool come up in the first video in this tutorial series when I am in the in-editor simulation or running things in VR. It's that little rectangle that is showing frame rates that pops up kind of around the waist of the user. And this is essentially that. It's just used to help diagnose frame rates and performance issues while you are running things. When you have the VR headset on, you can't look at the diagnostic tools of Unity. So it helps you see a diagnosis of performance while you have the headset on and are running things. It's also useful for seeing frame rates when you're running things in the in-editor simulation as well. But yeah, it's quite a useful tool. However, it's not as detailed as Unity's built-in diagnostic system, so it can only show you the basics. Now, MRTK also has its own shader that it uses for the majority of its materials, so this is just basically regarding that. MRTK also supports the detection of speech and audio and doing dictation and voice to text. So if you are wanting your application to deal with voice input, you can set that all up with MRTK, and there's some tools to help you with that. Next is the boundary system. Now, the boundary system essentially just involves the play space that you're working with in usually VR applications. So for example, when you're in VR applications, you need to say, okay, this is the maximum amount of area that I'm going to use and move around in. And you can visually identify that boundary for users if you desire. So you can turn this boundary on and off. You can have the floor present but not the walls. You can show the walls in some sort of semi-transparent grid, for example, or completely turn them off. And it's just a way to customize the representation of this boundary for users within your application if you desire. If you want to completely turn all the boundaries off so that you don't see any of that, that's perfectly fine too. And that's usually what I've done in the majority of my applications. Is that what was best for the use case of those applications? So the last main feature is the in-editor simulation. And this we've already covered in the first video in this tutorial series. And this is essentially just that MRTK allows you to simulate input by those simulated hands that we were using in the first video, to click on things within the Unity editor and to interact like you would with hand tracking or with VR controllers within the Unity editor without needing to put on a headset and deploy to a headset. And so this is just saying that this is one of the features that MRTK provides. And honestly, it's a very, very handy feature for developers, since we don't need to deploy to hardware every time we want to test the extended reality interactions. And the last feature on this list is the experimental features, which is just all the features that are in beta and is just sort of a catch-all for everything else that isn't yet officially released. So an example of this is if we scroll down, we can see 2 experimental features here. And so, for example, one is a dock that when you move objects onto these dock, they shift to predetermined positions and orientations, and are kind of stuck to there until you dock them out of it. And this is essentially just notifying us that we have access to all of these experimental features that are in beta and can include them in our projects if we wish. However, note that these are subjects to tweaks and change. So if you incorporate an experimental feature into your project, it might change before its official release, or it could be removed too as well. So just be aware of that. Now that we're done going through all these, as promised, I just wanted to go back up and touch on profiles here. So profiles relate to most of these in the way that a profile is essentially a group of settings regarding all the big features for MRTK. Essentially, the profiles group together your settings regarding things such as your input system, if you want to use spatial awareness or not, if you want to use the boundary system and in which ways you want to customize your boundary, if you want the diagnostic tool active, if you want your Mutli-Scene Manager to be used or not, if you want to use the detection of speech, if you want eye tracking or hand tracking active for that deployment, and essentially just a whole bunch of settings regarding what you want MRTK to do. Now, the reason behind it grouping everything under a profile is, let's say you want different settings for deploying to different devices, such as targeting an AR headset versus a VR headset, where they would need very different settings. Instead of needing to go through and adjust everything every time you want to switch, you can just save these profiles and then have them exactly how you want. And so when you want to switch, all you need to do is just switch the profile using a drop-down menu, and that's it. You just pick the profile. It now is in your settings that you want for deploying to an AR headset. You switch the profile to a different one. It's now in all your settings that relate to a VR headset. You now switch your profile again, and it is all your settings relating to a different VR headset, or for using MRTK, but through interactions via a mouse and keyboard. And so the profile system is really nice for allowing you to adjust all of the settings regarding these features really quickly and easily without having to tediously go back and change things and possibly forgetting to switch certain things when you're switching the target for your deployment. So yeah, now that we have taken a good look at all the main features of MRTK that are at our disposal to utilize, let's head back down to these user experience building blocks that we just briefly touched on previously and take a bit of a closer look. So, as was mentioned, these building blocks are essentially assets such as scripts and pre-built prefabs that MRTK has developed for us, which allow us to very quickly and easily implement user interfaces in AR/VR, as well as XR interactions with 3D objects in our scene. And this is very useful and saves a lot of time, as we don't need to tediously create these user interfaces or figure out the scripts for grabbing and moving objects or interacting with objects using AR/VR controllers, etc. And we can just use these building blocks in order to help us implement things, either by using their pre-built assets or using a combination of scripts together to create our own custom interactions and user interfaces. So I won't touch on all of these, as there is quite a few of them. And in fact, lots of the bottom ones are kind of combinations or build on the ones that are the most important up top here. However, if through the process of going through these, I don't touch on one of these that you are very interested in, I highly recommend you coming to this page and clicking on it. So for example, if you're interested in hand menus, you can click on this and it will bring you to a page regarding how they have set that up. And this can help guide you do the same thing yourself. So to start off, let's take a look at all the options that MRTK gives us for pre-built buttons. So MRTK has a fair amount of pre-built buttons for us that allow us to quickly implement 3D user interfaces within our project. As you may have seen in the last video, in that little demo scene that I was playing around in, there's a variety of them, from large, small, circle, square, collections of them, ones that you can toggle on and off, checkboxes, radial buttons, etc. And these are just enough to cover all of the basic types of buttons that we might want to work with. Now, these are very useful for the cases where we don't want to build custom UI and are happy with just quickly implementing these sort of standard looking buttons into our project in order to have a 3D user interface that immediately starts working with our application. However, if you want to make custom UIs, you can either take these prefabs and tweak them and customize them yourself, or you can use the scripts that these are based off of and make custom buttons and custom menu UI yourself. And we will be covering that in a future video. But very useful for just getting things quickly up and running within your Unity project. So the next building blocks that we come to are bounce control and object manipulator. Now, these are both scripts that we can place on game objects within our application if we want to allow users the ability to move, rotate, or scale these game objects around in 3D space. And they both do these in their own unique manner and thus have pros and cons to their approaches. And we will get into talking about both right now. So bounce control, you can only attach to game objects that have a box collider. And what it will do is it'll add these handles onto the edges and corners of the collider that act as user interfaces, which allow us to either rotate or scale the game object respectively. And the big strength to this rotation and scaling is very fine. So if we want to do very fine rotations along a certain local axis of the game object or scale things a very exact amount, this is a very nice way to do so. It also, being a method of one-handed rotation and scaling, is very natural and controlled rather than other methods of one-handed rotation and scaling that can be a bit more erratic in the way that they function. And lastly, one of the big benefits to this is the rotation and scaling is isolated from the other aspects of the transform. So what I mean by this is when you rotate with bounce control, it won't affect the translation or scale of the game object. And similarly, when you scale, it won't affect the rotation and translation. And this isolation is different from other methods that are a bit more freeform. And so it's very useful for these fine-tuned manipulations. Now, the biggest downside to this is it is a method of one-ended interaction that relies on clicking on very small handles, and thus it can be sometimes a bit hard to click these handles, especially if they're a bit further away. Also, as you may notice, I'm not talking about translation here, and that's because there are handles that are available for bounce control for translation. However, they're disabled by default because it's not a very natural way to translate the game objects when you could instead click on any portion of the game object and move it around. And so for this reason, bounce control is only really a good way to do one-handed rotation and scaling or fine rotation and scaling. And so to make up for the sort of downsides of bounce control, this brings us to Object Manipulator. Now, Object Manipulator, on the other hand, is a much more natural and freeform way to move, rotate, and scale objects about within an extended reality application. And the reason for this is it supports both one-handed and two-handed ways to do these motions using gestures that are reminiscent of how you would rotate, move, and scale objects in the real world. So for example, to scale an object, you can simply grab it with two hands and move them away like you're stretching it in order to scale objects up. Or if you want to rotate an object, you can grab it with two hands and just rotate your hands in reference to one another like you were turning a wheel, and it would rotate the object accordingly in your scene. Now, this freeform naturalness is one of the big strengths over bounce control, which can be sometimes a bit clunky or a bit less intuitive. However, the freeform nature is also its downside. So for example, you can't really rotate your objects around a single axis very easily unless that rotation is constrained. And that's because your hands can't really stay along one axis very easily, just naturally. Another thing is that the moving, rotation, and scaling are all connected. So let's say you're trying to scale the object up without rotating or moving it. This can be very hard to do with the object manipulator method of interaction. And it's for this reason that we often employ the use of both object manipulator and bounce control together, as Object Manipulator allows for a very natural way to translate with either one or two hands, as well as a natural freeform way to rotate and scale objects. However, Bounce Control balances out the weaknesses of Object Manipulator by allowing us a very fine way to do one-handed interactions with either rotation and scaling of our objects. And so together we can do both very macro freeform manipulations of our objects as well as fine manipulations of our objects. Now that we've talked about these two very important scripts, this brings us down to slates. So won't spend too much time on this, as slates are very simple. They're essentially just scrollable windows for 2D user interfaces, similar to a web browser or any application where you can scroll up and down within the 2D window. And this allows us to have interactable 2D either displays or user interfaces that we can just scroll up and down and interact with freely with either controllers or hands. Going on to the system keyboard here, what this is essentially letting us know is that MRTK allows us to bring up and use the keyboard that is native to the devices we are deploying to. So this is what the HoloLens 2's native keyboard looks like. The Quest's a native keyboard might look a bit differently, but MRTK allows us to, regardless of what type of device we are deploying to, bring up the native keyboard for that device and use that for text input. I will note that there is also a non-native keyboard that we can bring up that will be standardized across your different devices and across your different builds that MRTK also gives us access to. However, if you desire to use the native keyboard and when you deploy to different devices, it would adapt to the native keyboard of the device that you are deploying to, you can simply use MRTK to do so as well. So our next building block here is the Interactable script. And this script is very important. In fact, it is one of the most, if not the most, important script out of all of MRTK's UX building blocks. And the reason for this is that Interactable, with just the single script that you can pop on any game object, can turn that game object into something that responds to user input. And this input can be anything from physically touching it with hand tracking to clicking on it with a controller or even just speech. And these sources of input can do anything from changing the color of the object to scaling it, to moving it, to having audio play, to toggling it off, and even can throw events that can run scripts to do even more complex and custom types of interactions. So, for example, if you wanted to make a UI element that when you hover over it change color, Interactable handles that. And if that same UI element, when you click on it, it depresses a little bit like a button, then Interactable handles that. And when you depress it, it runs a script that then spawns in a visualization. Interactable can handle that. And then when you hover off of it, it then depresses and changes back to its initial color. Interactable is handling all of that stuff. And for this reason, it is actually the basis of many, if not all, of MRTK's buttons and most of its other UI elements. And if you go into the prefabs and look through them, you can see Interactable being on these. On the same note, it's not just limited to 3D UI like buttons and checkboxes and that sort of thing, but you can tie this to 2D user interfaces so long as they have a collider that Interactable can basically detect input through, or this can be attached to any 3D object in your scene. So simple spheres and 3D meshes and objects, or entire data visualizations. Basically anything that has a collider, Interactable can turn that into some type of user input. And this allows you to create really unique and original types of ways for users to interact with objects within your application and create really novel and custom UIs for extended reality applications. So as you can tell by how much I am raving about Interactable right now, it is a very useful and very powerful script that can really bring your application to the next level. However, since it can do so much, it can be a bit daunting at first to get a good grasp of it and everything that it can offer and how to set that up properly. And it's for this reason that I will be going through it in a future video to teach you how to apply it to game objects effectively and in a way that is easily understood. Since once you understand it, it's actually fairly straightforward. All right, so I won't rave anymore about Interactable here. So let's move on to our next building block here. Now we've already talked about solvers when we were talking about them up above here, so we'll skip over those just so we're not being redundant. And so the next building block here is the object collection. Now, the object collection is a very useful script. So what it does is we place it on a parent that has a whole bunch of game objects as its children. And what the script will do when we update it is it will place these children in a organized pattern that we define inside the script. So we can tell the object collection to be just flat along the same plane and place things vertically or horizontally, or a combination of the two, or we can even bring the object collection into 3D, and there's a variety of ways we can place the game objects that are the children of the parent. So for example, we can place them in sort of a cylindrical representation, in a radial representation, randomly scattered around the user, things like that. And it's very useful as it saves us a bunch of time, so that when we're trying to place things very nicely and in an ordered fashion, we don't need to do all the tinkering with the transforms ourselves. We can simply just line up the game objects underneath a parent, say update collection, and it will automatically adjust everything to be all evenly spaced and in the layout that we want it, both in 2D and 3D. So quite useful and saves us some time with just setting things up. So the next building block that we come to is pre-built tooltips for us. So these are essentially 3D tooltips that act just like your traditional two-dimensional tooltips that are essentially just labels on objects. So how these work is it's the label in the line is the tooltip itself, and you give it a position, and the tooltip script will essentially auto draw the line from the label to the position on the object there. And that line can be anything from a straight line to a Bezier curve to a spline, however you want it to look. And the nice thing about this script is that it will auto adjust the line if the labels move, or if the objects move around, the lines will just keep up with the object in the position that they're supposed to be tied to. And so this allows us to not have to worry about the math of the lines and have them always connect to their corresponding positions when you want to move objects around the scene. And it's a really useful and quick way to set up these sorts of labels without having to worry about all the tediousness of having your lines properly track the objects that they're tied to. So we're almost done now, and the remaining building blocks are fairly simple, so we'll go through them relatively quickly. The first is the pre-built 3D sliders that MRTK offers for us. Now, the standard Unity sliders are 2D, and so this gives us a nice 3D option that is better for extended reality 3D applications. These sliders can be either continuous in the way they function or discrete, and you can tie events to them so that when a value changes, it will update a object accordingly. And so they're quite handy so that we don't need to figure out all the math and the UI to build these ourselves. So they're just a nice, quick way to implement 3D sliders within our application. And after this, we won't go through the majority of these other ones, as we either talked about them above, such as the spatial awareness, or they are essentially pre-made assets that are built upon what we've just talked about above. So for example, the hand menu is simply using a solver to track the hand, and then we're using buttons which have interactable on them in order to perform interactions. The app bar is essentially the same thing, except the buttons are not tracked around the hand, they're just floating in space. And when you click on the buttons, they will bring up a bounce control that allows us to scale and rotate the object in the scene, and you get the picture. So the only really last one that we're going to touch on today here is the scrolling collection. And the reason why I just wanted to note this is this is essentially a combination of object collection and Slate, where essentially you have a collection of 3D objects, but this allows you to essentially scroll through them like you would a Slate, except now these are 3D objects that are in your scene, but bounded by some boundary that they disappear after they scroll past that. So it's a very useful script if you want to have a bit more three-dimensional looking user interface and have some scrolling functionality, but don't really know how to implement that yourself. You basically have a 3D Slate using this scrolling collection script. Now that we've gone through all of the most important user experience building blocks that MRTK has to offer for us, I hope you now have a better idea of why we use MRTK and how it can save us a lot of time and effort when developing all sorts of extended reality applications, especially in the area of implementing AR and VR object interactions and 3D user interfaces. Before we move on, though, I just want to encourage you to come back here if at any point in the future you would like to learn more about any of these features in more detail. This MRTK Unity developer support website has a wide variety of fairly detailed documentation regarding not only everything we talked about in this video, but also a whole section on a high-level overview of MRTK, as well as another one on building and deploying to different devices if you ever have issues doing so in the future. There is also an API guide for any of the classes within MRTK, which can be especially useful for debugging. One really useful thing too is that to access any of this, you don't even have to open a browser yourself. Throughout the scripts and assets of MRTK in Unity, there are little documentation buttons on them in the inspector that when clicked on bring you to their corresponding documentation. Very useful. All right, so now that we've gotten through this fairly comprehensive overview of MRTK and now know what tools are available to us for our XR applications, we shall be wrapping up the video here. In the next video, however, we will be diving into Unity and learning hands-on how to successfully implement the pre-made MRTK assets that we've learned about in this video into our very own XR application. But with that, this brings our second video in this series to a close. So, as usual, thank you all for watching. Hope you learned something. Watch for bears and jackal wares, and I'll see you in the next video.